We have seen that there is no real solution for this equation. X square plus 1 is equal to 0. Take this plus 1 the other side, so x square is minus 1. There is no real number whose square is minus 1. So when you take the square root on both sides, x is equal to plus or minus square root of minus 1. The square root of minus 1 is represented as I. So I is square root of minus 1. So when you square both sides, I square is minus 1. Then rectangular form of complex number. A complex number can be written as x plus I y, where x and y are real numbers. For example, 0 can be written as 0 plus 0i. So 0 is a real number, but it can be expressed as 0 plus 0i. So it's a complex number also. So complex number is an extension of real numbers. So 1 is a real number, but 1 can be written as 1 plus 0i. 2 can be written as 2 plus 0i. So when it is written like this, it's a complex number. That means 2 is a complex number also. It's a real number. So complex number is an extension of the real numbers. Now some more examples. 0 plus I3. You can write I3 or 3i. Now this x is called real part, y is called imaginary part. In this case, real part is 0, imaginary part is also 0. In this case, real part is 1, imaginary part is 0. Here, real part is 2, imaginary part is 0. In this case, real part is 0, imaginary part is 3. Now both can be irrational also. For example, root 5 plus I root 3. So this is a complex number. Then this is irrational. This is also irrational. 2 plus I3. Here real part is 2, imaginary part is 3. Here real part is 0. When real part is 0, this number is known as purely imaginary number. Lower classes, you studied how to represent real numbers. Real numbers are represented on a number line like this. 0, 1, 2, 3, the negative numbers this side. Then now let us see how to represent complex numbers. Complex numbers are represented like this: x plus I y, where x and y are real numbers. Here x is the real part, y is the imaginary part. Z is equal to 3 minus 4i. With each complex numbers, we can associate a ordered pair. Each complex number is uniquely represented by an ordered pair 3 comma minus 4. This is represented by 3 comma minus 4. So this is a real number 4. 4 can be written as 4 plus 0i. So 4 can be represented as 4 comma 0. Each complex number can be represented by a ordered pair. This is a purely imaginary number. 0 plus 3i. So it can be represented as 0 comma 3. It is to be represented on a plane. So here xy coordinates, and with each complex number we can associate a point. For example, this complex number is represented by the ordered pair 3 comma minus 4. X-axis 3, y-axis minus 4. So x-axis 3, y-axis minus 4. So it will be here. So this complex number is represented by this point. Now let us see this. It's a real number 4. So 4 comma 0. 4 comma 0. So it is here. say real number, so it is on the x-axis, so it is can be represented here, say pure, say real number. Now you see this is a purely imaginary number because the real part is 0, so it is 0 comma 3, x 0 y 3, so it is here, so it is on the y-axis. Real number will be on the x-axis, purely imaginary number will be on the y-axis. Next you see this number 3 plus 4i, so it can be represented by the ordered pair 3 comma 4. So x-axis 3, y-axis 4, so it is here. Now here both are positive, real part is also positive, imaginary part is also positive, so it is on the first quadrant. So here both are negative, real part is also negative, imaginary part is, so minus 3 comma minus 4, minus 3 comma minus 4 here. Then here second quadrant, if the number is in here, second quadrant means real part will be negative and imaginary part will be positive, so it is minus 3 plus 4i, minus 3 plus 4i, it will be here. So now we have seen that a complex number can be represented on a plane or a xy coordinate plane. So this plane is also known as Argand Plane. It is named after the Swiss mathematician Jean Argand. It is also known as complex plane. So a complex number can be represented by points. For each complex number there will be a point. Now a complex number can be represented in another way, that is by a vector. So this is the origin. So this 3 comma 4, so this complex number 3 plus 4i, either it can be represented by this point or it can be represented by this vector. Now 3 minus 4i, so it can be represented by this point or this vector. They are at equal distance from the origin, so magnitude is same but the direction is different. So for each complex number there will be a point, and each complex number can either be represented by a point or by a vector. I hope you have understood how to represent complex numbers on Argand Plane. Thank you for watching the video.